This is Geometry, Chapter 6, Section 5, in which we will be studying rhombi and squares. We've already talked about one special parallelogram, the rectangle. Another one is called the rhombus, and the plural for that is rhombi. All we're talking about with a rhombus is a parallelogram in which all four sides are congruent. Now, since it's a parallelogram, just like when we talked about the rectangle, since it's a parallelogram, everything we said about parallelograms is true. Everything back in 6.2, all the opposite sides are congruent, opposite sides are parallel. All of those properties are still valid. But a rhombus has a few other special properties too. Not only do the diagonals bisect each other, but they're also perpendicular to each other. And not only do they bisect each other, they also bisect the opposite angles, which is really nice to have for a rhombus. So we have a rhombus here, FGHJ, intersecting at point K. And our job is to find information from it. If FK is 5 and FG is 13, then our job is to find KJ, which at first glance seems nigh on impossible. But then we think about what we know about a rhombus. We know that the diagonals bisect each other and they're perpendicular. So we have a right angle right here. And whenever I see a triangle with a right angle in it, I immediately think Pythagorean theorem. A squared plus B squared equals C squared. So 5 squared plus KG squared equals 13 squared. Doing a little arithmetic, subtract the 25 and take the square root. KG is 12. Well, diagonals bisect each other, so if KG is 12, then KJ is also 12. Another problem, angle JFK is 6y plus 7, and angle KFG is 9y minus 5. What do we know about those two angles? Hopefully you're saying they're congruent because this diagonal bisects the big angle. So these two parts are congruent to each other. So 6y plus 7 is equal to 9y minus 5. Doing a little bit of algebra, we find out that y is 4. Okay, not too bad. You just have to think about the properties that are in play. So that's the niceties of the rhombus. Now when we talk about a square, you can think about a square in two different ways. You could say that a square is a rhombus that has 4 right angles. That would be accurate. You could also say that a square is a rectangle with 4 equal sides. That would be accurate as well. A square, technically speaking, is both a rhombus and a rectangle. It has all congruent sides and it has all congruent angles. So everything we learned last time about rectangles applies, and everything we just learned about a rhombus applies. Squares have all the properties of everything so far. And just like when we talked about rectangles last time, we have some tests to see if that's what we're dealing with, a rhombus or a square. Okay. And these tests are typically converses of the other one, of the properties that we had. So if the diagonals are perpendicular and we have a parallelogram, we have to be starting from a parallelogram. If the diagonals are perpendicular, then you have a rhombus. If you're starting from a parallelogram and one diagonal bisects both sets of both opposite angles, they're one pair, then you have a rhombus. If one pair of consecutive sides of a parallelogram are congruent, then you have a rhombus. And if a quadrilateral meets the descriptions to be a rectangle, and it also meets the description to be a rhombus, then you have a square. Okay. So the big key to testing for these things is diagonals. Okay. Suppose they give us some points and they ask us to decide if we have a rhombus, a rectangle, or a square. Now notice they're doing us a bit of a favor. They're telling me up front it's a parallelogram. Can you remember last time when we did the rectangle video, we had to first test to see if it was a parallelogram? Here they're telling us it is, so we don't have to test for that. So we can go straight to looking at the diagonals, and we have to ask ourselves two questions. Are they congruent? Because if they're congruent, that makes it a rectangle. Are they perpendicular? Because if they're perpendicular, that makes it a rhombus. And then if we get yes to both things, then we say it's also a square. So let's find the distances of the two diagonals. The length of JL, so doing the distance formula for J and L, a little arithmetic, we get the square root of 260. I don't care what that is, because I'm just going to compare it to the other one to see if I get the same answer. And diagonal KM, so I'm using K and M in the distance formula. And sure enough, I got 260 again, square root of 260. This tells me that since the diagonals are congruent, I have a rectangle so far. Okay. Could it also be a rhombus? Only one way to find out. We need to know if the diagonals are perpendicular or not. Well, let's find the slope of JL. And I get 7/4 time you reduce it. Let's find the slope of KM. And I get -4/7. And look at the two slopes. They're negative reciprocals of each other. Since they're negative reciprocals, that tells me they're perpendicular. So not only do I have a rectangle, I also have a rhombus. And if it's both, then Theorem 620 says it's also a square. So diagonals are key to deciding what you're dealing with. Are they congruent? That will tell you about rectangle. Are they perpendicular? That will tell you about rhombus. And if you said yes to both, that will tell you about square. Okay. As always, if you had questions along the way, hopefully you jot those down and bring them in to ask, and we will see you in class.